Okay, in the remainder of this week 5 material, we're going to take a look at a bunch of string handling functions. We already know various ways of interacting with and manipulating strings. We know how to use the plus for concatenating two strings together, and the star, the times, for doing repetition. So if I have s gets hi plus space world, s refers to the concatenation of those two strings, and s2 gets s times 4 means that s2 contains hello world, not hello world, hi world, hi world, hi world, hi world, so hi world 4 times. We can index into a string using square brackets. A string is a sequence like a list or a range or a tuple, and we can therefore use subscripts into it. So s sub 3 is the w. And we can also do slicing. So s sub colon 2 means all of the characters up to but not including character sub 2, and that's high. And we know about split. So if I say m gets s dot split, add a space, I end up with a list of 2 stirs. So that's more or less what we know. There are a slew of methods that you can use for changing strings, changing and testing their upper or lower caseness, searching for characters or substrings within strings, and you can go to this website here to get all the gory details. I've got them organized kind of by function here. In the documentation, they're, I think, more or less alphabetical. All right, so let's start out by setting s to the clever string. This is a test. All right, if I say s dot capitalize, now this does not modify s. What it does is to return to me a capitalized version of s, in which the first character in the string is made a capital letter. If I want to convert the entire thing to uppercase, I would say s dot upper. Okay? So capitalizing just means the first letter, and s dot upper means everything. Now, this method is a little odd. I don't know how useful it really is in real life, but if I say s dot title, then the first character in each word gets made uppercase. And if I have a string that has a mixture of cases in it, I'm just going to type some nonsense here, then lower will convert everything to lowercase. Okay, so we can capitalize the first letter, we can capitalize the first letter of each word, we can turn the whole string. Again, we're not modifying s here, but we can obtain an uppercase copy of s or obtain a lowercase copy of some string. Now, we can also do left and right justification and centering. So if s refers to word, 4 characters, and I say s2 gets s dot center 10, s is going to be, well, a copy of s, I should say, is going to be centered in a field 10 characters wide, and by default, spaces will be used to pad out those 10 characters. So since word is 4 characters, the upshot is that s2 is going to refer to a string that has 3 spaces, followed by the 4 characters in word, followed by 3 more spaces. All right, so here's s2, and I can confirm that s2 is 10 characters long. If I wish, I can change the fill character to be something other than space. So if I say S2 gets S dot center 10 with a hyphen, a string containing a dash. Now S2 has 3 hyphens or 3 dashes on either side of word instead of spaces. Ljust, I missed the L. Ljust and Rjust do what they sound like. They left justify and right justify a word within a field. S is still 4 characters wide. If I say S dot Ljust 10, then I get a 10 character wide field with word left justified followed by 6 spaces by default. I can also specify a fill character. So let me use dot in this case. Here I'm right justifying word in a field 10 characters wide, and I'm using dot rather than space to fill out the remaining 6 characters. Okay, so we can mess around with letter cases. We can also mess around with left and right justification and centering within a field of a certain width. Now, often when we get some input from a file or from a user, there will be spaces at the beginning or at the end that we perhaps don't want. Let's suppose that S contains 3 spaces, word, and 3 more spaces. So S is 10 characters long, and we decide we don't want any of those spaces around that word. If I say s.strip, then by default, all of the white space on the left side and the right side is stripped away. I have to be able to spell it correctly. Strip. Okay, and the spaces at the beginning and end are eliminated. There's an L strip and an R strip, which just strip characters on the left side or the right side, respectively. So S, when I said s.strip, that does not modify S. That simply returns to me a modified copy of S. And so if I say s.lstrip, only the left side spaces are eliminated, and likewise rstrip removes the right side spaces. Now, spaces are not the only white space characters that strip will remove. In addition to spaces, things like horizontal tabs, newline characters, carriage return characters, form feed characters, and so on are considered to be white space. So if I say something like this, line gets a horizontal tab, a space test, and a new line. Now if I print line, what I'm going to get is a tab, and then a space test, and then a carriage return. So I'll actually get an extra blank line of output. I said carriage return. I meant to say new line character. So this new line character will cause an extra line of output to be displayed. All right, so here's my tab, a test, and then I have the new line character dropping down an extra line. Remember that print adds a new line character itself. So if I print a new line character, I actually get two new line characters. I get the one that I asked to print, and then I get an extra one by default. All right, so line.strip is going to remove both the tab at the beginning and the new line at the end, whereas rstrip only removes the white space at the end. Now, here I want to be a little careful again. Let me create line 2 containing containing some spaces and a tab and some spaces, and ASDF and some spaces and a new line. Perhaps this is the line of input that I'm getting from a file or from the user. If I want to get rid of the two spaces and the new line at the end of that line, then I can say line2.rstrip to get rid of space space new line. But sometimes I might want to retain the spaces because the spaces are part of the information I'm interested in processing, and I may only wish to get rid of the new line character at the very end. In that case, you can ask for a slice. So if I say line 2 sub colon -1, now -1 is the index of the last character in a string, and what this means is give me all of the characters up to but not including that last character. So if you want to be careful to only remove the new line and not remove any other trailing space characters, remember this colon -1 trick as opposed to rstrip. Well, we can also test attributes of strings. We saw various functions we could use to convert certain characters to uppercase or lowercase. We can also test whether a string is uppercase or is lowercase, or is alphabetic or is numeric, and so on. I'm saying here f gets fantabulous, which is pointlessly long. For some reason, fantabulous just popped into my head. If I ask whether s is lower, well, every character in there is a lowercase letter, so this is true. Whereas if I ask, is it upper, that is false. Now, if I say s2 gets s dot upper, and then ask whether s2 is upper, of course, that is going to be true now. If I ask whether s is alpha, I'm testing whether it's alphabetic. I'm testing whether every character in it is alphabetic, and that is true. Is alnum checks for alphanumeric characters. So s certainly is alnum. There are no numeric characters in s, but all the other characters are alphabetical. If I ask whether s dot is numeric, that's false, because there are characters other than numbers in s. There's even a test I can do to check whether a certain string would be a valid Python identifier or not. Okay, so Route 66 follows the rules that the first character has to be a letter or an underscore, and the remaining characters have to be letters, underscores, or digits. Whereas 23 skidoo, on the other hand, is not a valid identifier. Because, of course, the 2 is a digit, not a letter or an underscore. Alrighty. Alright, well, I mentioned is numeric. If I ask whether the string 1, 2, 3, 4 is numeric, that is true. Now, if I have... Oops, I got rid of my this is a test. Let me turn s back into this is a test. And I can ask whether s is a title, and it's not. But if I say s dot title, s dot Okay, that is a title. Sorry, I got myself confused there. And if I ask whether s.title is a title, that's true. Notice here that s.title returns a string, and I can immediately apply another method to that string that was returned. So s.title is title gives me a true. I can ask whether all of the characters in a string are whitespace characters. Whitespace includes spaces, tabs, new lines, form feeds, carriage returns. Most of these characters you won't see in a typical program, but they're nevertheless valid ASCII characters. Carriage return, form feed, new line, horizontal tab. There's even something called a vertical tab, space. All of these things are whitespace characters. Well, split we know about. S I have returned to being this is a test. And we know that if I say m gets s.split at spaces, that m is going to be a list of 4 strings. Now the inverse of split is join, and so you might think, okay, I'm going to just say m.join with a space in between. But this, although it looks kind of logical, is not correct, because join is not a method that you can apply to a list. Join, instead, is a method that you apply to a string. And so basically what I have here are the 2 things I need, except they're backwards. What I need to say is space.join m. All right, and so around spaces, we're going to join together the strings in the iterable m. And there we are. Now I can also say things like space.join range 5. All right, range 5 is an iterable. Oh, fascinating. Now that's interesting. Not range, join. See, now it's claiming that it takes an iterable, but I guess that only means an iterable containing strings. Okay. Concatenate any number of strings. Okay. So I thought I had learned something new, but I fooled myself. All right. Now, you don't have to just use a space as your join string. I've still got my list m, and I can say s3 gets dot join m, and I will get 3 pluses between this is a test. I can find out how many times a certain substring occurs in a string by using the count method. Count will count either 1-character strings. Okay, this is a test, that's going to be 3 T's. This is a test is going to contain 2 substrings is. Okay, we've got one there and another one here. To be a little more detailed or a little more sophisticated than just counting the number of times that a character or a string occurs in some string, I can actually find the position of a string within some other string. So s is still, this is a test, and if I say s.find a t, well, it turns out that t is the very first character in the string. So what the find method is going to do is to report to me the index of the first little t that is in that string s. and that's just a 0. As an additional argument to find, I can specify not only the string I want to search for, but also the starting position that I want to start searching from. So if I found a little t at position 0, I can say, okay, neat, I found the first little t. Let's see where the next little t is, starting from position 1, which is where the h is located. And from there, we get, okay, position 10. Does that make sense? So here's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes. So the second little t is at position 10. And then continuing the same idea, I can see, well, okay, fine. Are there any more t's starting from position 11? And there's one at position 13. All right, very good. Let's see if there's another t beyond position 13. Well, actually, there are only a total of 14 characters in the string. So subscript 13 is the last character in the string. If the character does not exist, that is, in this case, there are no little t's in the string starting from position 14, I always get back a -1 for a failure to find the character. If I were to say s.find capital X, I would also get back a -1 because there is no capital X in there. All right? Well, in addition to looking for individual characters, of course, I can look for character strings. So s.find is tells me that that starts at position sub 2. All right, so here's position sub 2 with is. And then there's another one at position sub 5. Replace allows me to replace one character with another, or I should say one string with another string. And the default is that every occurrence of the first argument will be replaced by the second argument, not in the original string. So as with the other things we've been doing here, this is not going to modify the string s, but it is going to return to me a copy of s, and in that copy, little t will have been changed to capital T. And that change occurs everywhere by default. S contains this as test. I say s.replace little t, capital T. And all of the little t's got changed to capital T's. If I give a count as an additional argument, then that means I only want to change that many. So if I just say 1 here, then only the first little t gets changed to capital T. It's also possible to use replace to delete characters by simply replacing those characters with nothing. So here we have an empty string. s.replace t with no characters. And so now I have his is s with my 3 t's gone. I can replace one string with some arbitrary string. So if I say s.replace is with ABC, which is silly, it will nevertheless happen. And where I used to have is, now I have capital ABC everywhere. Okay, so we can modify the capitalization of strings. We can modify the justification of strings. We can search for things in strings. We can replace things in strings. We can count occurrences of substrings in other strings. One of the most important things to know how to do is how to format strings containing numeric values with certain field widths and certain precisions and so forth. And we've seen this format function before, but I want to go through it very systematically because it's important to know how. Let me backtrack a little. It is important to know one way, at least, of formatting arbitrary values in arbitrary configurations. All right, so we've mostly used format in strings that we have then printed, but actually format is a general formatting mechanism, and print doesn't need to be involved at all. Here I have, didn't quite format, there we go. I didn't highlight everything I wanted. So here I have a format string that has two fields in it specifying where values of what types should be formatted into the string. Okay, so each of these format codes, let me get rid of that highlighting entirely. Each of these begins with a curly brace colon. Now, you can specify which argument you want to plug in by specifying an argument number, but we're just going to put our format strings in the same order as our format arguments so that we don't have to worry about counting the arguments. All right, so we start out by saying curly brace colon, then little d indicates that we're going to just format a decimal integer, that is a base 10 integer. Little f, on the other hand, means that we're going to format a fixed point floating point number. 6 here is the field width for our decimal integer. 7 is the field width for our fixed point floating point number. And in the case of the floating point number, I can also specify the number of digits that I want to see after the decimal point. The less than symbol and the greater than symbol here between the colon and the field width specify that I want the integer to be left justified in that field that's 6 characters wide, whereas I want the floating point number to be formatted right justified in a field 7 characters wide. So if my first argument is the integer 1, 2, 3, 4, that's going to get formatted according to this format specification. It's going to be left justified in a field that is 6 characters wide. Okay, let me... Okay. And it won't let me highlight the spaces. All right, so that first field is 1, 2, 3, 4 space space. Now this comma that's coming out here is just a comma. Okay, comma is just the literal character in between these two format specifications, and so comma just displays as a comma. 7/3, which is the same as 2.33333, etc., is going to come out in a field that's 7 characters wide. 4 of those characters are going to be after the decimal point, which leaves the decimal point itself taking 1 character, and then I have 2 characters left to round out to my 7. So I'm going to get space 2 point and then 4 digits after the decimal point. All right, so that's a specific example, and now we're going to sort of build up the pieces of that. Basically, the C language provides a function called printf that has a very similar kind of format, a very similar kind of formatting language as the format function in Python. It's not exactly the same, but it's very, very close to the same. This format function operates on a string object, and it returns a string object where values that have been given as arguments to the format function have been plugged in place of the corresponding format codes in the format string. Any characters that are not within a part of a format code, like, by which I mean the curly brace, colon, blah, 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 close curly brace. Any characters that are outside of those notations are just preserved and passed through as is, such as this comma is just preserved and treated as a literal character and passed through as is in the output. Okay, so the simplest kind of format code that we can have just consists of the curly brace followed by the colon, and then one letter indicating the format specification for some value. And here are 4 possible letters that we can use there. There are even more than just these 4, but 4 is enough to worry about for the moment. If I have a D means a decimal or base 10 integer value. Okay? If I have an S, on the other hand, that means that I'm trying to format a string value. If I have an F or an E, both of these are formatting float values, but little f is little f is formatting that float value in fixed point notation. And what fixed point mean is that we require there to be a decimal point displayed, but we also require there not to be any exponent displayed. So let me show you over here one example of that. If I say, here's my format string, curly brace colon F, and let me specify that I want to have 5 characters after the decimal point. So I'm not going to specify a field width. I'm just going to say colon .5 F. That means that I'm going to display 5 characters after the decimal point for this floating point number. Now the value that I want to format is going to be 1 over 123,000 million, let's say. 1,230,000. Well, so that value is so small that when we display it to a precision of 5 digits after the decimal point, all of those digits are 0. That doesn't mean the value is 0. That just means that the displayed part of the value is 0. If I were to display that same value, and rather than asking for a fixed point output that does not have an exponent, I ask for an exponential output that does have an exponent, then I still get 5 digits after the decimal point, but I also get an exponent showing me the magnitude of that result. Okay, so that's the distinction between F, which does not display an exponent, and an E, which always does display an exponent. All right, here on slide 48 we have a very simple example using each one of these 4 format codes. So S gets, we are going to have a decimal integer, decimal meaning base 10, and then we're going to have a comma and a space. Those are just ordinary characters that are going to be preserved. Then I'm going to display a string followed by 2 dashes, and those dashes are outside the format code, so they're just preserved. Then I'm going to have a floating point number followed by a colon and a space, and then I'm going to have an exponential floating point number. There we are. So there's my format code, and now I'm going to say format. And so I've asked to display a decimal integer, therefore I have to give some integer value as the corresponding argument. Likewise, I've asked to display a string, therefore I have to give some kind of string as the corresponding argument. And the last two values are floating point numbers, so these need to be specified as float values, and I'll just use 7/3 in both cases. And I'm making use of the fact that division always produces a float. So even though I'm dividing int 7 by int 3, that gives me float 2.33333, etc. When I hit the enter key, S now contains, in place of curly brace colon D close curly, I have the base 10 integer 123. Then in place of curly brace colon S close curly, I have hello. In place of curly colon F close curly, I have this fixed point representation, 2.333333. Now, the default precision for floating point values is 6 decimal places, 6 digits after the decimal place. And then finally for the E, likewise, I have 6 digits after the decimal point by default, and I also have an exponent. Now in this case the exponent is 0, so that's 2.333333 times 10 to the 0 power. If you have a mismatch between the value that you're trying to display, in this example a Boolean value, and the format code that you use, in this case a string format code, you'll get yelled at. You'll get an exception. You'll get a value error complaint. Now, there are no format codes in the with the .format method for handling Boolean values or the special value none. Consequently, if you want to display the special value none, or if you want to display something for a Boolean value of true or false, you can convert the none value to a stir, which is just the 4 characters, capital N, little o, n, e. A Boolean you can convert either to an integer or to a stir. All right, if I convert true into an integer, that's a 1. If I convert false to an integer, that's a 0. On the other hand, if I convert true to a stir, that's the 4 characters, capital T, little rue, and likewise false is capital F, little alse. So those are your two choices for Booleans. You can either convert to an int or a stir. Well, actually, I mean, you could convert to a float. You could convert true to a float, and you'd get 1.0 as opposed to 1. All right, in between the colon and the format specifier character, you can specify the width that you want the character output field to occupy. So in this example, I'm saying I want 3 characters for the decimal integer. I want 3 characters for the string. And I want 15 characters wide for the fixed point, floating point value, and 15 for the exponential floating point value. And this time, rather than just printing 1 value, I'm going to print 5 values with k going from 0 up to 4. And so here's what my output looks like. Notice that notice that integer values are right justified by default, You can't see it here, but there are 2 spaces ahead of this 0, and 2 spaces ahead of this 1 and ahead of this 2. Strings, on the other hand, are left justified by default. So the string value comes out as 0 space space. And then these floating point values, either in fixed point format or exponential format, also come out right justified. So numeric values are right justified, string values are left justified in the output produced. All right, now in addition to specifying the width of the output field, you can indicate justification with, you can think of these 3 arrow symbols as sort of pointing to where the justification should be, to the left or centered. It does not want me to highlight that caret. There we go. So centering with the caret, or right justified with the greater than symbol. In the case of float values only, in addition to specifying the field width, you can also use a dot and specify the precision, that is the number of digits after the decimal point that you want to display. Okay, so we have various different format code letters that allow us to display integers in various formats, strings, and floating point numbers in various formats. We can specify how wide we want the output field to be. We can specify whether we want left, centered, or right justification. And in the case of float values, we can also specify the precision, that is the number of digits after the decimal point. And so here we have some more complicated examples showing these various formats. I don't think I'm going to. Well, let me highlight some of the details here. I will copy and paste these things, and then chat about them. So here's this for loop. In this for loop, whoops, I've got my indentation messed up. All right, let me hit the enter key now. In this for loop, we're only printing int values. We're printing 0, 1, and 2 as we range in this, as our loop ranges from through 0, 1, and 2, but not including 3. The first output is a decimal integer in a field 5 characters wide. You'll notice that by default that is right justified. So for numbers, right justification is the default. But I can specify left justification, centering, and right justification, and that's what I get in these fields here. I've just thrown in these vertical bars here as boundaries between the 5 output fields. Okay, so that's integer output. In this next example, I have floating point output, but in fixed output form. Actually here, because I have an opening parenthesis here, I don't actually have an indentation problem. I can just go ahead and hit the enter key. Okay, so I've got a field that's 17 characters wide with 2 digits after the decimal point, and so that's where I get my 0.43 here. It is right justified by default. I could have put a greater than symbol following the colon also as a way to force right justification. Then I have left justified, so the value is over on the left-hand side of the 17 character wide field. And here I have centered. Okay, so that value is centered. And then finally, this third example, again, I'm displaying floating point values, but this time in exponential format. And I've said that I want to have 9 digits after the decimal point for each of these. So I'm going to get 9 digits after the decimal point, and I'm going to get an exponent. Now, these are 17 characters wide. Okay, let's see. Let's check this out. I've got 9 characters here after the decimal point. 10, 11, 12, 13, 14, 15, including the E and the exponent, and then that leaves me 2 spaces in front. So each of these fields here is 17 characters wide, right justified by default, or left justified, or centered. So this stuff is dense, picky. It is worth forcing yourself to remember. It is worth memorizing this collection of format specification characters, because if you know this stuff well, you'll discover that you'll be able to print 99% of the kinds of values that you might ever want to print in a cleanly formatted way. And it's a pain to have to look this stuff up online every time you want to display something in a formatted fashion. So if you go ahead and devote the energy to experimenting with and memorizing this stuff, that will serve you well in the long run. All right, well, that gets us to the conclusion of the week 5 material. So take care and catch you next week.